Okay, so we are going to do one more problem for chapter 8 right here. Tarzan plans to cross a gorge by swinging in an arc. And I hope you guys can see my cursor. Maybe we'll try it this way. All right, so, and he's hanging from a vine, of course, and his arms are capable of exerting a force of 50 newtons. I'm just going to write that down on the vine, which is what's the maximum speed he can tolerate at the lowest point of the swing. So we want to find V. And then his mass is 78 kilograms. And the vine, the length of the vine, right, which is the radius of our circle, or this part of the circle, is 4.7 meters. Okay, so he's going to lift up and swing in a little part of a arc of a circle here, right, because his radius will be constant. And we want to find out what velocity he could tolerate and not lose grip on the vine. Okay, so let's take a look at that problem. So I just wrote down what we were given, right? We can draw our picture here of Tarzan. And taking onto a rope, and this radius is 4.7 meters. He's going to let go and swing in an arc of a circle, and hopefully land on the other side. Go Tarzan. So they want us to look at the problem right in the middle, kind of when he's at the lowest point of the swing. Okay, so our free body diagram at the bottom of the swing is going to look like this. So we have our dot representing Tarzan. We have force of gravity going down, and then we have tension going up. And it's got to be bigger so that we produce the acceleration needed to go in a circle. We can draw our coordinate axis here. Right? Our radial direction go toward the center of the circle, and then we have a tangent direction. Right? Things tangent to the circle. Okay, so it's a little worded, not really weird, but if we think what's happening to when you're holding onto a rope, right? You are actually using your arms to pull down on the rope. So this is the force of you on the rope. And the rope exerts an equal and opposite force. They don't look that equal. So this would be the force of the rope on you, right? So you actually pull down, right? You kind of pulling it down, and the rope pulls back up on you. So the force that we're looking at here is actually the force of the rope back on Tarzan. That's the upward direction. So this is what's going to be 1150 newtons, right? Because that's the max he can pull down. Therefore, it'll be the max that the rope can pull back up on him by the third law. Okay, so we can start with our general second law. Everything is going to go away except the radial direction, right? Our forces are only in the radial direction, so we can just kind of rewrite this now just for the radial direction. So for some of the forces in the radial direction is MAR, and again for circular motion, AR is V squared over R. So if we look at our free body diagram, that's where we get the forces from, right? So we can expand this out. And again, we said plus is toward the center of the circle. So anything opposite that will be negative. So when we sum our forces from the free body diagram, we have tension minus the force of gravity. The tension is toward the center, force of gravity is away. And then that's going to produce the acceleration that we need to go in a circle, mv squared over r. The force, right, is force times the acceleration. Okay. All right, and then we want to find v, right? This is what we're going to solve for. So we have tension minus mg equals m over r times v squared. And we can multiply both sides by r over m. I feel like we just did this. R over m. And then just swap sides. We get v squared is r over m, tension minus mg. And then we'll take the square root of both sides. So v is the square root of r over m. And then we'll do a tension minus mg. Okay, and now we can plug in. So the square root of R is 4.7 meters. The mass of Tarzan is 78 kilograms. And then we have our tension is 1150 newtons minus the mass again, which is 78 kilograms times the acceleration of gravity, 9.8 meters per second squared. Another good one. We'll close our square root. And then plug in. It's always good to check me. What I got was 4.82 meters per second. But pause and do the calculations yourself. Make sure I got the right answer. And circle that up. And that's that.